I'm Rob Rule. I'm the CEO of Entropix. We're a young biotech company based in the northwest of England, and we specialize in the development of enzymes. Enzymes are used in a whole range of applications, from foods to pharmaceuticals, from diagnostics to detergents. One of the challenges is that in order to improve the performance of enzymes, you can't simply tweak the enzyme directly. You have to go back to the gene sequence that gives rise to that enzyme, and then we gradually evolve the enzyme so that its performance meets the needs of that particular industrial application. We first came across VEC around about the time we began operating the company in 2021. I worked with VEC to design a proof of concept that would look at the prospect for analyzing gene sequences that give rise to enzymes and trying to match those gene sequences with the performance of the enzyme in the applications that we were looking at. We started the program with the aim of generating thousands of variants of an enzyme that's capable of degrading a very common plastic, PET. We would then assess all of those variants in terms of their performance and activity, and we'd also measure the DNA sequence of each of those variants. And the work that VEC did was to try to link the patterns that we could see in the DNA sequence to the performance of the enzyme.
After that, we wrote a joint UKRA bid to implement our work from the previous project, in which we were successful, and under this scope, we developed our vision for a machine learning pipeline. And currently, we start looking at different ways using the computer vision to speed up the other areas of Entropix workflow. We initially thought the potential for VEC to assist Entropix by integrating the machine learning into their enzyme engineering pipeline. We think that our expertise in data mining and modeling could significantly improve their research and development efforts, enable a more efficient and accurate enzyme design. However, we know data modeling, we know data mining, but we are lack of knowledge about enzyme engineering. So we kind of spent lots of time to familiarize ourselves with the underlying scientific principles and the specific requirements of the Entropix R&D process to provide a meaningful support.
Before our work with VEC, our expertise in machine learning was limited, but as we progressed through the project, we recruited a machine learning expert directly into our organization.
I'm Jodie Ashford, and I'm a computational biologist here at Entropix. So we use these technologies that have been developed by VEC with us in our daily data collection and analysis tasks. So this will be things like when we're validating the number of colonies on an agar plate in our colony counting tasks, and also in the validation of results on many of our visual phenotype assays. In addition to the image recognition work, we also use the machine learning pipeline developed by VEC to help us with a lot of our data analysis.
The project's been really beneficial for us, and the team from VEC really became like an extended part of our team.
Using the machine learning pipelines developed by VEC, hopefully we'll be able to uncover new insights in our data that we weren't previously aware of.
On top of that, then we've been impressed by the way that VEC has helped us with other aspects of our workflow as well. So not only have we been looking at DNA sequences, enzyme performance, but we've also looked at automation. As I mentioned, we often look at thousands of different enzymes and screen their performance. So automation techniques that help us with that are a great accelerator for our operations.